Hey, good evening. It is Monday, January 27th, and I think for the first time all winter we have a potential threat for a high-end storm. I will start off by saying it is not likely for that to happen, but if it does happen, it will be big. So I think you're dealing with a situation where maybe, you got 30%, maybe 40% chance of this coming to fruition for a big East Coast snowstorm, but if it does, it would be high end. So there's four pieces of energy running around that are very, very key here. So the first one this is the GFS valid for Friday morning. The first one is down over here, entering the western Gulf states. The second is down over here to the eastern Rockies. This system is actually moving down toward Mexico. And then this other third piece that's moving through the plains is just kind of meandering along in this general direction here. And then we've got this fourth piece up in Canada that's going to come into play later. And basically, the way these four short waves play around with each other is ultimately going to determine what sort of a storm system you get. So the first piece here, and let's just go clear this off here just so you can see it a little better as we move forward, is this big fat mess that's entering the western Gulf states. If I back this up 24 hours or so to Thursday morning, you can see it starts off as this shortwave back over the desert. And exactly how much of this ejects out and what it looks like is going to be very, very uncertain. The model's going to do a bad job handling this, which is a huge problem right off the bat, because they're not going to know exactly where to place a low as it starts coming into the Gulf. And while this is happening, you have this secondary piece that's diving almost due south down the eastern side of the Rockies. Many of the models actually end up leaving this behind back over West Texas and Mexico. And then you've got this other piece that is moving through the plains that, as it moves east, has the potential to phase with this system, with our southern system, what's left over of piece number one. So this was piece number 3 here, and original piece number 1 down over here. And there's two possibilities for phasing back out here in the plains. Number one is this piece number 2, this Rockies piece could potentially phase with this over Texas. And number 2, you could get interaction between the northern stream piece here over the plains and the southern stream piece as it ejects out to the east. This is the 18Z run of the GFS. This is just one depiction of it. This is not necessarily how it's going to happen. But the way these three pieces all end up playing around with each other, whether they interact or, very possibly as well, don't interact, are all going to set the table for the storm further down the road. The more phasing, the more interacting you get back over here, the more likely you are to get a big storm once it reaches this area over here. And if we run this forward, I can show you why. So in this particular run of the GFS, this is 18Z, there was a little bit more phasing than there was at 12Z. Now, let me see if I can just clear that off. So as this thing starts to exit, these two pieces start to interact, and our fourth piece starts aggressively diving in. You can see that here. So these first two pieces kind of come together off the Carolina coast. They go up off Cape Cod, and the rest of it comes diving in behind. Now, if you look at the way these 500 millibar maps work, and we can actually zoom in a little bit, another version of this model run here, just to give you a little better idea. This is the piece here. That this lead piece is what's going to create the storm. So these are the pieces right here coming off of Delmarva. So this is hour 120 here, and it's valid 18Z Saturday. So if we take this 500 millibar image and then switch off to a surface image. So let's go back here again. Hour 120, you can see this is where the lead energy is. Now let's go to the surface. This is where the storm is. So it's this initial piece of energy here that is creating the storm. Now, as we watch this go forward, I'm going to move it forward at 500 millibar first. Watch this piece as it starts heading northeast. 1, 2. This is 12 hours. You can see it starting to wrap up in the Gulf of Maine at this point. If we do the same thing on the surface map, watch what the low does. It drives up into the Gulf of Maine and explodes into a 970 millibar low. And what's going to be key about this is this is exploding into this extremely powerful low with a ton of energy being left behind. Because if you go back and look at this, look at all of this energy that's back over North Carolina, Virginia, and Delmarva. All of this was not used by the low because it missed the connection. So even though you have an exploding low, you have an exploding low because you have a negatively tilted trough inside of a positively tilted one. It's a very unusual setup. Let me pull it up here where I can draw it a little bit clearer. So this is your broad negatively tilted, or positively tilted trough, excuse me, that's coming in, that's oriented in this direction. But then you also, remember, this back over here is where your storm is. You have a negatively tilted trough tilted in this direction on the eastern side of it. So this is, the negative tilt in this trough is what causes it to explode. But it's doing so while leaving the bulk of the energy behind. And if you look at what happens here, this is, look at the timestamp here, 1:20. This is only 2 frames later. Hour 1:32, 12 hours, so it's 12 hours. 12 hours later, all of this energy is crashing in to where the original low was. So you only need this original low to be about 12 hours slower to get a titanic collision in the atmosphere between these different pieces of energy. And again, you may say, well, that's 12 hours. Well, if you do the math between here and here, that's hundreds of miles. It's really not hundreds of miles, because in order to get a 500-600 mile swing in this area here, you only need a 100 or 200 mile swing when it's back over here. Because the more phasing and the more interacting you get back over here, the more the system is going to want to cut off. And the more it wants to cut off, the more it's going to try to slow down. And the more it slows down, the more likely this is to catch it. And the more likely this is to catch it, the more that's going to start interacting. And you're just going to create a positive feedback loop. So everything that happens early on, these little mesoscale features, are going to keep compounding on themselves until we finally get to where the storm is going to be off the East Coast or way out in the Atlantic, which I think is still the slightly more likely solution, just because the pattern has been so aggressive, so progressive. But when you have this much energy flying around, anything can happen. You can start having collisions, and then it just forms a chain reaction sort of events. And the problem is, the global models are not going to be able to tell you how those little mesoscale pieces are going to interact. We need the mesoscale models. We need the NAM. We need the RGEM. We need the HRR model. And those are not going to be available for a couple more days. So you're going to probably continue to see these enormous swings in results. And just to go to the ensemble map here. This is, again, let's go out here to this is 108, so let's go up to 120, let's go to day 5. These are the ensembles. All these little numbers here represent low pressure systems, and watch what happens from Saturday afternoon, and we go overnight in the next 12 to 18 hours, how much we see just an explosion in some of these lows. Look at this, 950 millibars. Now, if we just compare this to what the regular GFS was showing at this point, right? Let's get the hour correct here, 138, match it to 138. The regular GFS is already up in Nova Scotia at this point. Look at this. Most of these GFS ensembles are a little bit further south and west, which means they're a little slower than the GFS, which means the GFS is a progressive bias model. So maybe instead of 12 hours, you'll need 9 hours now before that other piece catches it. And that's really, really significant because, again, if this initial piece is just 5 or 6 hours slower, early on, it's easily going to be 10 or 12 hours slower by the time you get to the East Coast. It just keeps compounding. And this is why, even if you look at a low that's hundreds of miles off the coast, it could easily come back. Very, very similar to the way the Boxing Day storm did in 2010. I'm not telling you it will come back. I am telling you that it is, don't be shocked if it does and you see a massive snowstorm sitting there on Saturday night, because it's very, very possible. These models are already showing with the negatively tilted trough embedded in there, a 965 millibar low off Nova Scotia. If this gets caught by that piece, that's the Saskatchewan Screamer that's diving down across the Great Lakes on Saturday morning, it will be a nuke somewhere in this facility. So several days to watch it. We'll continue to discuss it in the threads, and until then, I will see you later. All right.